Hi National 5, so as usual, starter, 3 questions. First question, draw NBr3 showing how the outer electrons are involved in bonding. So I want you to draw a Lewis diagram of that. Question 2, I want you to balance this equation. Okay, so remember the order that we're balancing. We balance group ions first, then metals, then non-metals, then hydrogen and oxygen. Question 3, I want you to write the formula for lithium oxide and I want you to write the formula for beryllium hydroxide. Okay, so for both you need to do SVSSF. As usual, pause the video, complete the starter, and then I'm going to go through the answers just now. Okay, so question 1. Draw NBr3 showing how the outer electrons are involved in bonding. Now, nitrogen is the centre atom, okay? There's less of them. So we do N with a circle. Now, we're only interested in outer electrons, remember, because they're the only electrons that are involved in bonding. So if we look at nitrogen, nitrogen's in group 5, so it's got 5 outer electrons. So we can draw them in. Okay, so 1, 2, 3, 4, and then we begin to pair up 5. Yeah? Now we've got 3 BRs, so we've got 1 BR there, 1 BR there, and 1 BR there. Yeah, just note that they're always paired up with the single electrons. Yeah, because it's single electrons that are involved in bonding. Now, I'm going to skip a step because I've not got the space here, but I'm just going to overlap them already. Okay? Now, if we look at bromine, you should have realised is in group 7, so it's got 7 outer electrons. So we're not interested in the inner, but only interested in the outer electrons. So, bromine has 7, so we put 1 in there, and remember, because it's a different element, we put circles instead of X's. And so that's 1, 2, 3, 4, 5, 6, 7. Yeah, and if you do that for them all, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. And that is our Lewis diagram there. And remember, what's important is that because it's bonding, why do atoms want to bond? They want to bond because they want to become stable. They want a full outer shell. And you'll notice that every element has that now. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. So that's a full outer shell. And each bromine also has 1, 2, 3, 4, 5, 6, 7, 8 outer electrons. Okay, and if we were drawing the 2D shape, it would look like that. Yeah, forget that wee bit at the top. Right, question 2, balance this equation. So again, remember what I said, we balance our group ions first. Do we have a group ion? Yes, we do. NO3 on both sides. Yeah, then we balance the metals. Okay, so we've got 2 metals, we've got Ag, and we've got beryllium. Now it doesn't matter what one you put first, makes no difference. And then we balance our non-metals, which we have as chlorine, and next one we balance our hydrogens or oxygens, but we don't have any, so we don't need to balance them. Okay, now on the left we have 1 NO3, to the right of the arrow we have 2 NO3, on the left we've got 1 silver, on the right we have 1 silver, on the left we've got 1 barium, on the right we've got 1 barium, and on the left we've got 2 chlorine, yeah, Cl2, and on the right we've only got 1 chlorine. Yeah? Now, obviously this isn't balanced, so start at the top and then work your way down. Okay? So, we start with NO3. What side do we start on? We start on the lowest side, so that's there. So what number times 1 would give us 2? That would be 2. And where do we put that? We put the 2 where the NO3 is. Okay, so this becomes 2 NO3, but we also multiply the Ag as well. Okay, so this comes to 2 Ag. So we've balanced the group ions, but we've then unbalanced the Ag. Okay, now Ag, the lowest number, we're on the right side. So in order to make that the same as that, we multiply it by 2, we find where Ag is, and we put a 2. Okay, so 2 times Ag goes to 2, 2 times chlorine also goes to 2, and if you look at that, we have now balanced the equation. Yeah, so well done if you got that. Next one, write the formula for lithium oxide. So we need to do SVSSF. This doesn't contain any group ions, okay, because it doesn't end in 8 or 8, and it doesn't contain ammonium or hydroxide. So our symbols are just Li for lithium, O for oxygen. Lithium's in group 1, so it's got a valency of 1. Oxygen is in group 6, so that's got a valency of 2. Remember the valencies go 1, 2, 3, 4, 3, 2, 1, 0. Do they simplify? No, they don't. We then swap them. Okay, so our formula should be Li2O. Well done if you got that. Again, do SVSSF. Beryllium is Be, and we do have a group ion this time, which is hydroxide, so that is OH if you use page 8 of the data book, if I remember correctly. Beryllium is in group 2, so it's got a valency of 2. Hydroxide is in column 1, so it's got a valency of 1. Okay, they don't simplify. Switch them, so that becomes 1 and 2. So our formula is Be, and remember this is the tricky part, because we've got more than one group ion, we need to put it in brackets, and we put the 2 outside the bracket, okay? And that multiplies everything in the bracket. So it's Be bracket OH close bracket 2. Yeah, well done if you got that. Right, our heading today is going to be diatomic elements. Okay. Right, now, you should know, because we've discussed it before in class, that a diatomic element, forget that, diatomic means 2 atoms, okay? Di means 2, like carbon dioxide means that we've got 2 oxygens. Atomic just means atom, atoms, so diatomic literally just means 2 atoms, okay? And an example of that would be H2. Another example would be HF, like that, okay? So we've got 2 atoms, HH, that's 2. We've got 2 atoms, that's HF. Yeah? Now, what you need to know is there are 7 diatomic elements in the periodic table. Okay, and you need to memorize these 7 diatomic elements, and they're quite easy to memorize because we use something called H north down. Okay, now what I mean by that, if I get my periodic table, H is hydrogen, north yeah, is nitrogen, oxygen, fluorine, and then down is the elements down from fluorine all the way to iodine. Okay, so that's H, north, down. Okay, that's the best way to memorise that. So that's hydrogen, which is H2, nitrogen, which is N2, oxygen, O2, fluorine, F2, chlorine, Cl2, bromine, Br2, and finally iodine, I2. Okay, so that's your 7 diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine and iodine. Okay, now make this wee note so you can also get diatomic molecules containing different elements. Okay, so these are 7 diatomic elements because they only contain one type of atom, so hydrogen, nitrogen, oxygen, so on. But you can also get diatomic molecules containing different elements. So that could be like carbon monoxide. Yeah, that is just CO. You could also get hydrogen chloride, which would just be HCl. You could get hydrogen fluoride, which would be HF, which we've discussed up there already. You could get hydrogen bromide, which would be HBr. There's quite a lot of them, but just note, if there's only 2 atoms, that makes it a diatomic molecule. Okay, now just make a wee note here. Note that CO2 is not diatomic, and I want you to think, why is CO2 not diatomic? And quite simply, it's because it contains 3 atoms. 1, 2, 3. So this wouldn't be diatomic, it would be triatomic. So note that CO2 is not diatomic as it contains 3 atoms, not 2. Okay, and that's how we do that. So I want you to put the subheading now. As we are going to do the Lewis diagrams, and we'll do them of a few of the diatomic elements. Okay, so again, we'll do this very quickly because we've already done hydrogen, so we'll do hydrogen, which is H2, and again, that should just be H, and again, if we look at our periodic table, hydrogen's only got 1 element, so you put 1 electron there, put another electron there, so they're facing each other. Okay, and remember, it's these 2 here that attract, and it would look like that. Okay, remember the overlap and that shared pair of electrons. Yeah, remember, a shared pair of electrons, that's your covalent bond. Okay, and if we did the 2D drawing of that, that's there. Okay, so that line there just represents the shared pair of electrons. Again, we did this yesterday as well, but let's just do fluorine. F2, remember, because it's one of our 7 diatomics. Fluorine is in group 7, so it's got 7 outer electrons. Okay, and that's all we're interested in when we do Lewis diagrams, is your outer electrons. So we do F, and then 7, 1, 2, 3, 4, 5, 6, 7. And remember, you want to have your single electron facing the other element. Okay, so it looks like that. They bond. Remember to do the overlap. And because they're the same element, remember we can just keep them all as X's. Now, what we're going to do now is we're going to do oxygen. Now this is a very, very tricky one. Okay. Now if we look at oxygen, oxygen's in group 6. It's got 6 outer electrons. Okay. Now you'll see why this is difficult in a second. So we do oxygen and we start putting in our 6 electrons. So 1, 2, 3, 4, 5, 6. Okay. Now you'll see oxygen has 2 single electrons. Okay, so what I'm going to do is I'm going to try and line this up with the other oxygen. Okay, so 1, 2, 3, 4, 5, 6. Now what happens, because each oxygen has 2 single pair, each oxygen has 2 single electrons, they have to both overlap, like so. Yeah? And this is how it makes, this is why oxygen is very difficult. So if we do that, okay, so let's do 1 oxygen, okay? So what should happen is in the overlap we should have 1, 2, 3, 4 electrons. Now I'm going to do that. Well, that's terrible, but anyway. So in that overlap there should be 1, 2, 3, 4. Okay? Now, in this oxygen there's 2 pairs. Okay, so 1, 2 pairs. In that oxygen there's 1, 2 pairs, so 1, 2. And that is how we draw oxygen. Yeah, very difficult, very, very difficult. Now, you'll notice in there, okay, that is 2 shared pair of electrons. Okay, now because a shared pair of electrons classified as a covalent bond, if we've got 2 shared pair of electrons, we're going to have 2 covalent bonds. Okay, therefore oxygen, if we draw the 2D shape of oxygen, it would look like that. Okay, so instead of a single covalent bond, because oxygen sharing 2 shared pair of electrons, we call that a double covalent bond. Yeah, a double bond. Very tricky that. Okay, now as if this couldn't get any harder, it actually does. we're going to do nitrogen. Okay. Now this is as hard as it will go. It will not get any harder than this. But if we look at nitrogen, nitrogen's in group 5. So it's got 5 outer electrons, 2, 5. So if we draw one nitrogen, it would look like this. 1, 2, 3, 4, 5. And I'm keeping my double bond, my pair of electrons on the left hand side, because I want all my single electrons sort of facing to the right. Now if I draw another nitrogen, 1, 2, 3, 4, 5. What's going to happen is that these single bonds electrons, are going to overlap. Okay, so what we should have in the overlap now is 1, 2, 3, 4, 5, 6 electrons. Okay, so if we try and draw this can be quite difficult. Okay, so we should have 1, 2, 3, 4, 5, 6 electrons in here. 1, 2, 3, 4, 5, 6. You'll notice that the right nitrogen's got a pair of electrons there, and the left nitrogen has a pair of electrons on the left. Okay, so this here, because we have 3 shared pair of electrons, okay, that means we're going to have 3 covalent bonds. And if we draw nitrogen, nitrogen would look like that. Okay, nitrogen has a triple covalent bond. Okay, and that is tricky. It's difficult. Okay, so get this in, take it in, see if it makes sense. I'll do another example. Okay, I'm going to go for carbon dioxide this time. Okay, now carbon is the centre atom, yeah, less of them. And I'm going to, if we look at our periodic table, carbon's in group 4, so it's got 4 outer electrons. Yeah, so 1, 2, 3, 4. And you'll notice that I'm putting them in the corners this time, but you'll see why I'm doing that. Now oxygen, yeah, oxygen's in group 6, so it's got 6 outer electrons. And because it's a different element, we need to do circles, so that's 1, 2, 3, 4, 5, 6, yeah. And if we do the same for the other oxygen, 1, 2, 3, 4, 5, 6, yeah, you'll see what happens is those share and those begin to share. Yeah, so if we overlap this, what happens is on the left overlap, we should have 1, 2, 3, 4 electrons, X, O, X, O. On the right side, on the right overlap, we should have 1, 2, 3, 4 electrons, X, O, X, X, O, X, O. Okay. On the right hand side of the oxygen, we have 2 pair of electrons. And then on the left hand side of the oxygen, we have 1, 2, 3, 4, or 2 pairs of electrons. Okay, so we've got, that's our bonding electrons. We've got two pairs. We've got an XO, XO, and we've got two pairs here, XO, XO. So if we draw that out, carbon dioxide would look like this. O, double bond, C, double bond, O. Yeah? And that's what that looks like. Right, I'm going to do one more, and I think that will probably be us for today. We are going to do HCN. Okay, so our middle atom is carbon, yeah, and you should know carbon's got a valency of, carbon's in group 4, so it's got 4 outer electrons. 1, 2, 3, 4. Yeah, doesn't matter where you put the hydrogen, just keep it on the left. Hydrogen's only got 1 outer electron, it's a different element, so you would put circle. And nitrogen is in group 5, so nitrogen has 5. 1, 2, 3, 4, and I'll put the electron there because I want these 3 lining up. Now what happens is these 2 overlap, and these 6 electrons overlap. Okay, now what happens if we do this overlap? Do the hydrogen first, yeah, that's an XO overlapping. And with this one, nitrogen, yeah, you'll notice that there's 1, 2, 3 pairs, yeah, XO, XO, XO. So we need to write that XO, XO, XO. And you'll notice nitrogen also has a single pair there. Okay, and again, because these are bonded, every element should have a full outer shell. Hydrogen has 1, 2 in its first shell. Remember, 2 electrons can fit in the first shell. Carbon, outer shell, has 1, 2, 3, 4, 5, 6, 7, 8. So that's stable. And nitrogen should also have 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so every atom should now have a full outer shell of electrons. Okay, and that's how we do that. So we'll leave it there. If you finish, I'll put up some questions for us to do in teams, and this should be my last lesson on YouTube because I should be back on Wednesday. Right, thank you.